Bringing together data is a fundamental skill in data science, data engineering, and data analysis. Whether it's to create new features, enrich an existing dataset with another dataset, or filter a dataset using the values from another dataset, you are going to want to know how to merge or join that data. Hey folks, I'm Trent. I'm a professional data engineer and have been for the past 5 years. And in this video, I wanted to show you how to merge or join data in Pandas. To do this, I'll take you through some of the terminology that we use when discussing merges or joins, then go through some practical examples, and finally, at the end of the video, discuss some of the advanced merge techniques available in Pandas, so stick around for that. To start things off, let's go through some of the basic terminology we use when we discuss merges or joins. The merge or join operation brings together two data frames to produce another new data frame. The way in which we combine these data frames is the kind of how or the operation or type of join that we want to do. To show you this, the two data frames are typically referred to as the left data frame and the right data frame. These are just semantic labels that we use for the data frames. It's basically which data frame appears first, that being the left data frame, and then the second data frame being the right data frame if we read our code from left to right. Then we can also discuss how we combine the data or the different types of combinations we can have in our data. In the context of Pandas, an outer will refer to all of the data available to us, both in the left-hand side data frame and the right-hand side data frame. It is all records from both sides. The inner would be the matches between the two data frames or data that appears in both data frames based on a key. I'll describe a key in a minute. In the context of Pandas, when we refer to a left type join, we're referring to what is typically known as a left inner join in other SQL dialects. This is all the data in the left data frame, including the data which matches from the right. Equivalently, a right type join or right type merge is all the data in the right-hand side data frame, including that which matches in the left. Now, you may hear of different types of joins in SQL or in other libraries, things like left inner, left outer, full outer. Now, these are just the types of joins, or I'm describing the joins to you in the context of Pandas. It's worthwhile to look at all those different types of joins available when you're using different libraries or packages. Usually they're very similar in terms of the context, and it's easy to pick up on if you know the basics. I'll leave a link in the description to a full description of all the different types of joins available in SQL that also shows a really nice visual representation. But this should be enough for the purposes of this video. As I was going through this picture, I mentioned the concept of keys, and this is how we determine what is or what is not a match in our two data frames. To show you this practically, at the bottom over here on the left hand side I have our left data frame or left data, and on the right hand side our right data, and I have this column called key col in both of the data frames. Now, we determine matches by the values of our key column or key columns. We can use multiple columns as well, but in this context, if I was speaking about the left in the context of Pandas, what I'd be referring to is all the data on the left hand side, so records 1, 2, and 3, and then including the data on the right hand side which has a match, so that would be these records 1 and 2 excluding record 5. Now, if I was speaking about the inner between these two data frames, it would purely be the matches between the two. So that would be records 1 and 2 matching with records 1 and 2 on the right hand side, excluding records 5 and 3 on both the left and right hand side because they do not match, or there are no matches in both the left hand side and right hand side data frames. Equivalently, on the right hand side, if I was speaking about the right, it would simply be all the records on the right hand side, including the matches on the left hand side and excluding the non-match on the left hand side. And then lastly, just to describe an outer, it would be all of the records, so 1, 2, 3, 1, 2, and 5 as well. All right, let's be real. I don't like PowerPoints. You don't like PowerPoints. Let's get into the practical applications of merging or joining in Pandas. All right, so I have my editor open over here and a notebook that I've created. If you want to follow along, I'll leave a link to my GitHub and this notebook in the description below. To start things off, I'm going to be using Pandas and only Pandas, so be sure you have Pandas installed, and we'll go ahead and import Pandas as PD, as all good notebooks should start. So to start things off, we are going to look at an inner merge or join. I'll differentiate between merge and join in a second in the context of pandas. I might use those terms interchangeably. I mean, in our context, they basically mean the same thing. Let's say you work for a company that has a website, and you have a set of data that represents the users of that website, as well as a signups data set or data frame that represents whether or not a particular user signed up to receive marketing information and what their marketing preferences are. So in the first data frame over here, we have our full set of users. And in the second data frame over here, this records users that have indicated that they are happy to receive marketing information and the preference or the channel preference, the way in which they want to receive that marketing information. So for example, we have email or SMS over here. And then in the user data, we have the email address and phone number of the different users. So what we want to do is bring together these two data sets to produce, or data frames, should I say, and produce a new data frame which represents the users which are happy to receive marketing information and the channel that they prefer to receive marketing information on. Now, to be completely honest, I usually uncheck those boxes, so I would not be in the signups list. What's critical to note is that we have a user ID in both of these data frames, and this is what we're going to use as our key, the way to determine matches, the column that helps us determine what matches or which records match in our left-hand side and right-hand side data frames. To combine these two data frames, we are now going to do our very first merge. So I'm going to create a new data frame. Let me bring this up a little bit, called merged df, and then set this equal to firstly our users, which is going to represent our left data frame, dot, then use the method merge on this data frame. And the very first argument that we specify is our right-hand side data frame. You can actually see that in the IntelliSense over here, where it says right. This is going to be our other data frame. And in this case, it is going to be the signups data frame. So we're specifying that we have our users data frame. We want to merge it with the signups data frame. We are then going to specify a key with the keyword, a bit confusing there, but the keyword for the method of on, and specify user ID, because this appears in both the left-hand side and right-hand side data frame. And then we're going to specify a how. So this is the type of merge that we are doing. In this case, we would want to do an inner merge, because the information that we're looking for is users that are happy to receive marketing emails and their marketing preferences, right? We're going to get those preferences, but it is only users who have agreed. We don't actually want to include any users who have not agreed to receive marketing information. So that is why we are choosing to do an inner merge. So let's go ahead and print out our results and run this. And we can see the resultant over here is a new data frame wherein we have our user information along with their marketing preference over here. So we've got our user Frodo Baggins, who prefers to receive marketing information via email, and we have their email address over here. So note, we only have users who have actually signed up to receive marketing information, and we have excluded or dropped the other users who did not appear in the signups data frame. And that is the effect of an inner join. Now, on that point, in Pandas, there is a method for joining as well, or a method called join. The only difference really is that a join will be done on a data frame's index. So the index column, which is this column over here, this is an auto-generated index because I didn't specify one earlier, but the join operator will only work on indices. That's the difference, the real difference between a merge and join in Pandas. So just to show you what I mean, I will repeat this, but use the join method instead of the merge method. So let's go ahead and create a new code block. And as I said, a join uses indices. Now, we can't do an inner join on purely the indices over here because these are not the user IDs, right? For example, user ID 6 over here maps to an index of 3. But if I were to use this as my key, this would map to this index over here in the user's data frame, and that's incorrect, right? Because this person is not necessarily the same as index 3 on the sign-up side. We have to use user ID. So we need to set our indices before doing the join. To do that, let's go ahead and specify users.setIndex, set index, and specify our keys. So keys equals user ID. And we want to do this operation in place. So this is just saying that I'm going to do the operation in one line and not reassign my data frame. I'm going to do it all on top of the existing data frame. That's all that in place means. All right, so if we do this, let's just take a look at a printout of what we get. So setting the index has now created or used the user ID as the index of the data frame, and we've gotten rid of the auto-generated index. Cool, so we're just going to repeat this for our signups info as well. So let's duplicate this and instead use signups over here. So we've set our indices, and now we can go ahead and say joined df for join data frame and do users.join, and we want to join with signups. The how is via an inner join. And notice that I have not specified an on for the join because by default it's going to use the index. The only time I'd specify an on is if I had a multi-level or multi-index, so an index that is comprised of multiple columns. In this case, I'm just going to use the existing index, which is a single index of user ID. Let's go ahead and print this out, join df. Ooh, we've got a key error over here. So this is because I'm trying to repeat a set index operation on top of users when I've already set the index. So it's saying that user ID is no longer a column. My mistake. I can just do that. So I'm not going to repeat the operation. It is already the index. So in this case, I just needed to set the index of signups. Sorry about that. All right, but we can see with the corrected code now that we get exactly the same result. But of course, our user ID is now our index. There isn't an auto-generated index, but the result of the join or merge operation, in this case, it's a join, is the same. We get our users. So if we actually look at these pretty close together, we get exactly the same result. So all of these user IDs are appearing over here. We get the user and their marketing preference. Now, my preference is to use the merge operator in Pandas rather than join. Now, it's worthwhile noting that join is slightly more efficient because it is using indices or using the indexes of a data frame. But really, I've never come across a case where I've needed to use a join instead of a merge or really gotten enough of a performance benefit to justify using join over merge. I prefer using merge because it's more flexible, but that's just personal preference. You can use join if you want, noting of course that you need to be very aware of the indexes of your data frame if you're going to use join. So we've dealt with inner joins. Let's deal with the other types of joins available to us in Pandas, that being the left, right, and outer merges or joins. In this example, I'm going to once again produce two different data frames. One of them is going to be our employees data frame. So let's say you have a list of employees over here, and we have another data frame representing departments in our business that our employees work at, right? So we have employees and departments. And as our first question or our first result that we want to produce, we want to find out which department an employee belongs to, or which department each employee belongs to. To achieve that, let's add another code block over here. I'm actually going to collapse these two just to make it easier to see. So in this case, we are going to leverage the department ID over here because it appears in both of the data frames, and we're going to use that as our join or merge key. All right, so let's produce another merged data frame over here and set this equal to first employees.merge, and we want to merge with departments on. We said that our key is the department ID, and then the how we want to merge. If we're answering the question of which departments do all the employees belong to, we want to do a left merge or left join to answer that question. Why? Is because we want to keep all of our employees irrespective of whether or not they have a department, and only append or attach the department data onto our employees' data frame. So this is a typical case when you're doing things like data enrichment, when you're bringing together two data sources. One of them is a base table, or it's referred to as a base table or base data frame, and you want to add some data to that base data frame. This is just the kind of terminology that I've heard throughout my career. People use the term base to represent the kind of like full data set that you're dealing with, and then you are effectively merging onto that full data set. All right, and what's noteworthy over here is that the department ID of some of our employees over here is -1. You'll often see this in databases where if a particular record does not have a matching record in another table, or in this case data frame, it will be represented by something like a -1 or -99 or something like that, basically a default value. All right, let's go ahead and merge our data frames and see what result we get. So we determined that we want to do a left over here, and let's go ahead and print out our new merge data frame to look at the result. Alrighty, so we can see we got our full list of employees back, so all of the employee data, and appended to this is the department information. So we can see that Michael Scott, the regional manager, is in department 1, which happens to be the sales department. Now, an interesting case is our records which do not have a department ID. These come back as nans, or not a number, basically nulls. And this shows you that with a left join, we don't actually filter our left data frame by the matches on the right. If we did an inner join over here, we would drop the records that did not have any department IDs, but that's not what we want. Now, to illustrate a right join to you, it's very similar to a left join, but of course now we're going to take the full set of data on the right hand side and basically append the data on the left to it. So let's take a look at that. Basically, I'm going to repeat this code over here. So let's steal that, save us some time, and I'm going to specify right instead of left, and let's see what result we get. So in this case, you can see that we get all of the departments back with the employee data appended to the department. And interestingly, we can now see that one of the departments actually has no employees. That is the admin department over here, or administration has no employees. So this answers the question of which departments have or do not have employees. So if you were interested in that kind of question, you would use a right join in this case. Of course, you could just switch the order of the data frames, put departments first and then employees, and use a left join to achieve the same result. But I just wanted to illustrate to you what a right join does. So left and right, very similar. It's simply the semantics of where you put the data frame in your operation. Alrighty, so using the same example, I wanted to illustrate to you what an outer join is as well. So what we said before is that an outer join is all of the data from both sides, whether or not they have matches. So if we run this, we can see we get back all of our employees and all of our departments, irrespective of matches. So you can see we have our records that do not have a department over here, and we have our departments that do not have any employees. Now, this is interesting if you wanted to see or answer the kinds of questions like, do all of my employees belong to a particular department, or do all of my departments actually have employees? Perhaps maybe the data is misrepresenting something, or someone has a made-up department appearing or something like that. An interesting feature of the merge method is this keyword of indicator over here. So if I add indicator and set that to true and rerun this, this actually adds yet another column to our data frame, this underscore merge column. And this tells us if the data appears in the left only, so does it only appear on the left-hand side? So these are employees which do not have departments, or if they're in both, so these are employees that actually do have departments, so these employee IDs have corresponding department IDs. And then lastly, if a particular record is on the right-hand side only. So these are departments without any employees. This is interesting if you are trying to reconcile two data frames or two data sets together and want to understand which appears or which records appear in both the left or the right. This just gives you a quick filter option over here. And this has been very handy to me in the past. Now, there is one more type of join that I wanted to explore that I actually didn't represent on the picture earlier. So this is the cross join. This produces a Cartesian product between two data frames. If you're not familiar with what a Cartesian product is, effectively it's just a combination or all the combinations of records available. So to make this clear, let's say you had a data frame representing different stores and another data frame representing all products that you want to sell at your stores. So over here, we have 3 different stores from the Harry Potter universe. And let's say now we want each store to start selling all the different products we have available. So they need to sell a Phoenix Feather Wand, a Chocolate Frog, and extendable ears at each of these stores. And we needed now to produce a data frame representing all the combinations of stores and products. That would be a resulting Cartesian product between the 2 different data frames. So to show you this, let's actually go ahead and do that. Let's create our cross-merged df. Let's take our different stores, .merge that with products. And then we are only going to specify a how. So in the case of a cross merge, we don't need to specify a key because we're not really interested in keys or matches. We are interested in all of the different combinations irrespective of matches. So in this case, we don't actually need to specify anything further. We can just go ahead and print out our cross merged df. Alrighty, and we can see we've gotten each of the combinations of store to product over here. So this repeats the store and then repeats the sets of products. So actually what you'd want to look at is we could filter this data frame by adding a little filter here. So let's say store underscore name, and we want product underscore name over here. Let's just rerun that, and we can see our resulting data frame a little bit clearer here. We weren't actually interested in the IDs before. Now that actually covers all of the different types of joins in Pandas. What I want to move on to are some of the more advanced features and advanced merges or joins that are available in Pandas that I think are quite cool. So let's take a look at that. The first advanced feature that I want to take you through when merging data frames in Pandas is that of validating cardinality. If you're not familiar with cardinality, it's just a fancy way of saying the type of relationship between the keys in your data frames. It'll become more clear when I go through the example, but effectively it's things like you expect your keys to be one-to-one, i.e. for every key in the left-hand side, there is exactly one key on the right-hand side. And on the right-hand side, there's exactly one key on the left-hand side as well. That's just an example of one-to-one. There are other types like one-to-many, many-to-many, or many-to-one. But let's go through a practical example. I'm going to use the employees and departments example again, and just to illustrate this. So let's create or recreate our employees data frame. So exactly the same as we had before, and our departments data frame over here. I'm actually going to collapse these. Ooh, not the actual data frame, the code. With that collapsed, I'm now going to create another code block over here. So let's say we were doing our left merge again. So let's create our merge data frame, and once again specify employees.merge with our departments over here, and then specify on our key of department ID, and how we want to do this is our left again. It's fine. And the keyword we want to add is the keyword of validate. So if I open up the quotes over here, so departments on validate, we can see that the IntelliSense opens up the different types of validations we can perform. So we've got one-to-one, one-to-many, many-to-one, or many-to-many. So if we go over this, one-to-one checks if the merge keys are unique in both the left and right datasets. By that, I mean we are looking if the keys, so the key of department ID over here, is one-to-one. Basically, for one employee, there is exactly one department, and then on the department side, there is exactly one employee. Now, that's not necessarily true, right? Because a department can have many employees, but an employee can technically only have one department, or at least I'm assuming that in this example, you might have data sets where someone is allowed to belong to multiple departments, but in this example, it's not the case. We are saying that an employee can have exactly one department, but a department can have many employees. So to show you what will happen, I'm going to go ahead and specify one-to-one over here. knowing that this is incorrect. So we've specified 1 to 1. And if we run this, we get a merge error. And if we scroll down to the output over here, all the way down, we can see that the error message tells us that the merge keys are not unique in the left dataset. So this is not a 1-to-1 merge. And that's exactly right, because we know that a department can have many employees. So we know the type of cardinality that we're dealing with is not a 1-to-1 cardinality. Instead, it should be a many-to-1, right? Many employees can map to one department. So if I specify that instead, so many to one over here as I validate, and I run this, I actually get an output. I forgot to print it out. So let's actually go ahead and print out our merged data frame just to show you that it's the same thing. So merged df over here, and we get the result that we had before for our left merge. This type of validation is useful when you're doing analysis on your different data frames and you're assuming cardinalities, especially when you're dealing with really big data sets and you're not able to actually check the cardinality. I mean, we're using pretty small data sets here, but if you had a really big data set and weren't sure what the cardinality was, you could test for it by using the different validation options. You could also make this part of a data pipeline if you wanted to be sure of the cardinality before actually merging the data together. So you could specify the type of cardinality to look out for, and then if the data is incorrect and defies that cardinality, you could throw an error and handle that in different ways. Maybe you just want to stop your pipeline completely. Nonetheless, I think that this is pretty cool and pretty useful to use. The next more advanced technique that I want to describe is when you have multiple matching keys or need to use multiple keys to perform your join. So going through the example that I have prepared over here, let's say you had a data frame of transactions over here. So different transactions performed by different customers. And these transactions were to convert currency or perform Forex, a Forex exchange. So for example, Darth Vader is converting 100 euro into US dollars on this date over here. Then we wanted to convert or merge this with some Forex data to convert the currency into a base currency of, let's say, US dollars. So you wanted to standardize the currency into US dollars. You would then need Forex rates. So that's our second data frame over here. So we've got our currency pairs and a daily rate for each of those currency pairs. So euro to dollar is 1.1, and the rate date time, which is just, in this case, just a date representing the daily rate or the rate for that particular date. And we can see we get multiple instances of a currency pair because the rates can change per day, or we get different daily rates, right? So euro to USD over here for the 10th of August was 1.1, but on the 11th it was 1.2. So the rates change over time. So to perform this merge, to join the two data frames together, we want to perform a left join so that we get our rates on our transactions. But the thing is, we can't just use currency pair, right? Because it's not unique. If I just used euro to USD and mapped it into the Forex rates data over here, I have two instances of euro to USD. So which one should I use? The answer is that we want to use the date to indicate which rate to use. So we would also specify not just the currency pair, but also the rate date time in our merge. So let's go ahead and do that. So the setup is very similar. All we're going to do is specify firstly our merged df again, and we want to take our transactions dot merge with our Forex rates over here. Now this is where we change or deviate from what we were doing before. We can now specify a left on over here. So left on, or the keys that we want to use from the left-hand side data frame, so our transactions data frame, and we can actually specify a list of values, not just a single value. So we're going to specify currency pair, as well as the, what did we call it? Transaction date time. So let's go ahead and specify a transaction date time. I'm actually going to reformat this so it's a bit easier to read. Transaction date time. Yeah, cool. So left on that. And then we can specify our right on, so the keys from our right-hand data frame, as currency pair as well. So again, currency underscore pair. And then this is called a rate date time. So the name is slightly different. Now the ordering matters here, right? Because we're matching currency pair to currency pair and then transaction date time to rate date time. So it's important to remember the order. We shouldn't switch these around. Right? And I'm missing a comma. Cool. And then lastly, we want to specify how we want to merge these. We said that we were going to do a left type of merge. All right, let's print out our result and see what we get. I'm missing a comma. There we go. Alrighty, so our resultant data frame is all of our transactions because we did a left join and our left is the transactions data frame. And we can see we get our daily rates over here for each of the currency pairs at the same date time that we want. So this date time is the 10th of August, this date time is the 10th of August, and the currency pair over here is Euro to USD. And we can then go ahead and multiply our amount in base currency by the daily rate to get a result in USD. Just to, for completeness sake, to show you what I mean, we can now do something like this. Merge data frame, we're going to create a new column called, let's say, amount USD is equal to merge df amount in base currency multiplied by merged df and the daily rate over here. And let's print that out to show you what I mean. All right, so at the end over here, we then can get a standardized currency on the other side. This is just to show you what I meant earlier, what we were trying to achieve by doing this merge or why we're doing this merge. All right, the last advanced merging technique that I wanted to show you in Pandas is an approximate merge. Now I'm going to repeat the example we had before in a little more detail. Let's say we had a transactions table, but this time our transactions actually had a proper date time, so not just a date. Instead, it captured down to the minute when the transaction was going to happen or when the transaction happened. And further, let's say that our Forex rates data, in this example, we received our Forex currency pairs every half an hour, right? So over here, we got our Euro to USD rate at 10, and then got our Euro to USD rate again at 10:30. This is the same for each of the currency pairs. So you can imagine receiving or getting Forex data every half hour. Now the complexity comes in when we don't have a date time that matches exactly with the date time for which we have a rate over here. So our transaction occurs at a time that for which we don't have an exact match in our Forex data frame over here. We can overcome this by using an approximate merge in Pandas. Now the syntax is very similar, but the operator is a little different. The first thing we actually want to do is make sure that our data frame is in the right order. We are doing or merging time series data in this case. So what we want to do is first just ensure that our data is in the correct order. And by order, I'm referring to the timestamps. So let's go ahead and do that. So what I want to do is take transactions equals transactions dot sort values, and we want to use the transaction date time over here. Yeah, I'm happy with the sort like that. And then we're going to repeat this for Forex rates. So Forex rates equals Forex rates dot sort values. This time it is going to be on the rate date time. So this just sorts the values on the date times. We're just sorting them in, I believe by default, it is ascending order, which is completely fine. So now we want to do an approx merge. So let's create a new data frame called approx merged df. And in this case, we actually need to call our approximate merge operator directly from Pandas. We can't do it on top of the data frame directly. So previously we were specifying the data frame over here. So specifying the data frame and then calling the merge method on top of that data frame. The operator that I'm going to use is actually in Pandas, the package itself, not on the data frames in Pandas, if that makes sense. So all I mean is that I need to call pd.merge as of, right over here. So pd.merge as of represents our approximate merge. Now the syntax is very similar, but we now need to specify our left data frame first. So our left data frame is going to be transactions, then our right data frame next, which is going to be Forex rates over here. We need to specify first a by, or the by keyword. All the by keyword does is specifies a first merge, or like what we are going to merge on first and then perform our approximate merge. So this is going to be an exact merge, and then we are going to do an approximate merge as a second layer. So our by keyword in this case is going to be the currency pair, right? Because we want to merge by currency pair first and then do an approximate merge on the date times. All right, so that's our by. And then we want to do our left on. So our left on is the approximate merge key that we want to use from the left hand side. So that is our transaction date time over here. And then our right on over here, which is the rate date time. All right, that looks all good to me. Then I'm going to specify a how as we did before. So how equals left, and then specify another keyword that's new, which is a direction. So this will become more apparent when I show you the different examples of directions, but this specifies how to look for a nearest neighbor, or the neighbor that we want to use to merge on, or these date times over here. We want to specify which approximate date time to use. So I'm going to say nearest. This is the one that I normally use over here. This just means when I'm looking at date times, use the nearest corresponding date time to perform the match. So to make this more apparent, let's go ahead with approximate merge df, and I've specified a how. Oops. So approximate merges you do not specify a how. Instead, you are by default effectively doing a left join in every case. So in the case of a approximate merge or approximate join, we are typically doing a left, but we do not specify or cannot specify a how. All right, so our resultant value, or our resultant data frame over here, which is a left join or left approximate join, approximate merge over here, is our transaction. So all of our transactions, and we can see we get our amounts back, our currency pairs back, and then our transaction date times over here, along with the matching rate date time, or approximately matched rate date time. So we can see over here our date time is 10:07, but our nearest match in the Forex rates data frame was at 10 o'clock. Whereas for this transaction that happened at 10:25, our nearest match is at 10:30 in our Forex data frame. Similarly, the nearest data frame for 10:35 and 10:50 is 10:30. Our rates only go up to 10:30 in this example. So to illustrate to you the different types of directions, this uses the closest. If I specified backward over here, backward, this is going to round down, look for the nearest floor. So the nearest value that is rounded down. This should be more apparent when I show you the example. So in the case of the second transaction over here, it is now using 10 o'clock because I'm rounding down to the nearest neighbor. Whereas the rounding down to the nearest neighbor for 10:35 is 10:30. So this one changed because I'm now doing floor rounding in terms of how I find the nearest neighbor. Similarly, I can use forward, which will round up. But you'll notice that our last two transactions actually don't have matches in this case, because if I were to round up from 10:35, I would expect 11, or round up from 10:50, I would expect 11 again. And in our Forex rates data frame, we do not have an 11 o'clock. All right, so that concludes our discussion on merges or joins in Pandas. We went over the theory of how joins between two data frames work. We then went through some practical examples of the different types of joins in Pandas, and then finally went over some more advanced features in Pandas using the different validations available to us, approximate joins, and looking at using multiple join keys. If you have any questions or comments, let me know in the comments below. I'd love to hear from you. And if you found this video useful, please do consider giving it a like and subscribing to the channel for more data engineering, data science, and data analytics content. And now that you know how to combine datasets in Pandas, how do you go about filling in missing data in your Pandas data frame? You can check out my video on data interpolation using Pandas to learn more. Thanks so much for watching, and I'll see you soon.